Hello everyone, my name is Iadamiki Iakai from Assam Don Bosco University, and today we are going to talk about a very fun topic in physics. It's all about the Kepler's laws of planetary motion. Well, the Kepler's laws of planetary motion are laws which describes the motion of planets in the solar system. They were all first derived by the German astronomer Johannes Kepler. There are three laws of planetary motion. Let us talk about them one by one. Kepler's first law of planetary motion, also known as the laws of ellipses, stated as all planets move about the Sun in elliptical orbits having the Sun as one of the foci. This means that planets are orbiting the Sun in a path described as an ellipse. This is the picture of an ellipse. Suppose this ellipse is where the planet Earth moves. The Earth moves in the ellipse around the Sun, where the Sun is located at one of the foci of the ellipse. Now, let us move on to the second law of planetary motion. The second law of planetary motion, also known as the law of equal areas, stated as a radius vector joining any planet to the Sun sweeps out equal areas in equal length of time. The second law describes the speed at which any given planet moves while orbiting the Sun. When the planet is close to the Sun, it moves fast, but when it is far from it, it moves slow. So if we draw an imaginary line of the movement of the planet and the Sun for every month of the year, we can see that when the planet is close to the Sun, it will form a wide but short triangle, and when the planet is far from the Sun, it will form a thin but long triangle. The Earth would have to adjust its movement in order to match the imaginary area. Did you know that Kepler's second law of planetary motion is proof importance of Newton's laws of gravitation? It's getting interesting, right? We'll see about that later. Now, let us move on to the Kepler's third law of planetary motion, which is sometimes referred to as the laws of harmonies, stated as the squares of the sidereal periods of the planets are directly proportional to the cubes of their mean distances from the Sun. It compares the orbital periods and radius orbit of the planets to those of other planets. It is the ratio of the periods to the cubes of their average distances from the Sun is the same for every planet. The comparison of most planets can be shown in next illustration. Shown in this illustration now, what does that mean? Kepler's third law means how long a planet takes to go around the Sun, which is its period. It's related to the planet's mean distance from the Sun. That is, the square of the period divided by the cube of the mean distance is equal to a constant. And for every planet, no matter what its period or distance, d squared by r cubed is the same for every planet. And that is all. I hope you enjoyed the video and you enjoy physics.